All right, welcome to day 2. Your homework will be packet pages 8 and 9. So this will be your first homework assignment that you're doing. Uh, the homework will always be due the next class period, so this will be due tomorrow. And what you will do, regardless if you are remote or in class on the day it's due, by 5 a.m. that morning, you'll take pictures and upload them to the assignment on Schoology. So it's probably unlikely that you'll be up at 5 a.m. So the purpose for having it at that time is so that you do it the night before. So I want you to be doing it the night that it's assigned. So tonight you'll go through, you'll do packet page 8, packet page 9. You'll take pictures of each of them, and then you'll go to the assignment on Schoology and just upload those. Okay, so again, they have to be in by 5 a.m. on the day it's due, and that'll always be the case whether you're in class or you're remote, because in class, uh, they don't want us walking around towards each of you in your desks, so I can't go around and check the homework, so this will alleviate that. So we have a warm-up. So on your warm-up sheet, you can pick a side to start, and in the Monday box, we're going to solve this by factoring, just like we did on Friday. So our goal is to get it equal to 0. When we are in class with these, you'll do it on your own for a couple minutes, or when on most days when you're remote and live, you'll have a couple minutes to do it on your own. But because you're just watching a video asynchronously, we'll just go through and do this one. So we'll subtract the 12 on both sides to get it equal to 0. We want to think about what adds to 4 and multiplies to negative 12. If we want to multiply to a negative, we know it's got to be 1 positive and 1 negative. And because it's adding to a positive 4, the bigger of those two has to be positive. So that means we could have positive 12 and negative 1. We could have positive 6 and negative 2, or positive 4 and negative 3. That's the only stuff we could possibly have to match our signs. And the one that adds to 4 is the positive 6 and the x minus 2. So then we'll set each of those equal to 0. Now I get questions a lot of time. Can we just skip that step? And can we just automatically say that x equals negative 6 and x equals 2? Can we jump right to that after the parentheses? Well, the question is kind of. I am okay if you jump from here to here, but you need to understand that this is the next step, because we will eventually see things like 3x minus 7, 2x plus 1 equals 0. And you'll need to know, well, what values of x do we have for that? So you need to understand, oh, we're just doing 3x minus 7 equals 0, and 2x plus 1 equals 0, and then we can just work to get x by itself. So as long as you understand that we are setting those equal to 0 and solving, I'm okay if you skip to that bottom. But it's good to every now and then just refresh your memory and show the equal 0 and solve it. So we are going to be in our packets today. And this will be on packet page 3. Packet page 3. So we're going to solve systems of equations, and the two methods we're going to look at for our algebraic methods of doing that are elimination and substitution. First, we're going to do substitution. So in substitution, you need to have one of the variables by itself. You sub that into the other equation and then solve, and then sub back into either equation to find the other variable. So we want to try and see what variables can be easiest to get by itself. Well, in this example, we really have two options. We can either get the y by itself in the top equation, or we can get the x by itself in the bottom equation. It doesn't matter. It'll be similar difficulty level. Either way, you just got to pick one and go with it. So let's maybe do the top one. Let's get y by itself. So we can add the 3x to each side. So that's going to give us y equals 5 plus 3x. So now what we'll do in the second equation is the 5 plus 3x is going to be substituted in for y. So we're going to have x minus 2 and then start a parenthesis because what we're subbing in has multiple terms to it. A term is, each term is separated by addition or subtraction. So 5 is one term, 3x is another term. So we have 5 plus 3x, and then that equals the negative 15. So in solving this, the first thing we should go about doing is our distributive property. We've got the negative 2 in front of our parentheses. Now you need to remember to distribute this as a negative 2. That's a common error to not distribute the negative with it. So we'll have x minus 10. Then we'll have a negative 6x when we multiply the negative 2 through equals negative 15. On the left, we'll combine like terms. We've got a positive 1x and a negative 6x, which would give us negative 5x minus 10. And that's equal to negative 15. We'll add that 10 over. And that'll give us negative 5x equals negative 5. And we're one step away. We can divide by negative 5 to give us x is equal to 1. Now, it's important to note, when solving a system of equations, graphically what we're really doing is we're finding where two lines cross on a graph. So the solution should be a point, an x and a y. So if you just get one of the variables, you have to remember to sub back in. So we got x equals 1. So let's maybe sub into the neatened up version that we had. And you could sub in here, you could sub it in either of the original equations, you'll get the same answer. So we have y equals 5 plus 3, or in other words, y equals 8. Now I personally like to then write that as a point, just to reinforce the idea that really we just found the point where two lines are crossing, we just did it algebraically. So that's substitution. Substitution is good if you can easily get a variable by itself. Sometimes in the process of getting a variable by itself, on the other side you might have some fractions and things like that that would make it more challenging to solve when you substitute in. So because of that, we also have another method that helps us avoid fractions and things like that, and it is elimination. So in elimination, you want to put both equations in standard form. Standard form means you want both variables on the one side and the constant on the other. It doesn't really matter which is which, but often we see the variables on the left and the constant over on the right. A constant is a term that has no variables, so like the 5 or the negative 15 in this example. Then we have to try and get in front our coefficient in front of one of our variables to be the same number but different signs. So think like 3 and negative 3. So let's maybe see if we can get up to there, and then we'll talk about the other steps. So first, we want the x's above the x's and the y's above the y's. So I'm going to rewrite this first equation as negative 3x plus y equals 5. Notice each thing kept its sign, because we didn't move it from one side of the equation to the other, we just rearranged it on its own side. All right, now we have to make a choice. Do we want to get the x's to match up, but just opposite signs, or the y's to match up with opposite signs? And in this particular case, they're both relatively the same difficulty level. Maybe let's try and get the y's to match up. If we want to get the y's to match up, we probably want to multiply the top by positive 2, because that would give us 2y, and then that would pair with the negative 2y to eliminate. So we always want to get the same number but different signs. So we'll multiply the 2 through to everything, including the other side of the equal sign. So we'll get negative 6x plus 2y is equal to 10. So this equation looks different, but it's actually the same as the original top equation, because if you just divided everything by 2, you're right back to where we started. So a lot of times in math, what you do is you make things look different, but you don't change their value. If you think about it, that's what you're doing when you say reduce a fraction, or when you get a common denominator with a fraction. You're changing what it looks like, but you're not changing the value of it at all. So we changed what this looked like, but not the value of that top equation, so it'll be convenient for us to do the third step now, where we add the two equations. And that's why it's important to have opposite signs for the ones we're trying to match up, so that they will add to 0. So adding the x's will give us negative 5x. 2y and negative 2y to 0, that's gone. And then we have negative 5 over on the right side. If we divide both sides by negative 5, we end up getting x is equal to 1. Well, we can sub that back into either equation. I'm going to go ahead and sub it into the first equation. So we'll have second equation. 1 minus 2y is equal to negative 15. I just subbed the 1 in for the x here. Subtract the 1. Negative 2y equals negative 16. And when I divide by negative 2, I'll get y equals 8. So we get 1 comma 8 as our answer. And I didn't mention it before, but notice our equations were the same equations that we did for the substitution example. And although we did it with different methods, we got the exact same answer. So we're going to practice a few of these now. So we want to solve this one algebraically. The way that it is set up in the original problem, it probably lends ourselves to do this with elimination, because it'll be at least 2 steps to get any variable by itself. So let's go ahead and we'll do elimination. And we've got to choose to get either the x's or the y's. It's going to be similar difficulty. So let's maybe go with the y's because they already have opposite signs. If you can't think of the lowest thing, you can always just multiply them by each other. So the top we can multiply by a 3 and the bottom by a 2. In this case, that also is the lowest as well. That will give us the least common multiple. So if we multiply the top, we'll get 9x minus 6y equals 30. One of the most common errors with this is people forget to multiply it to the right side. And we'll get 6x plus 6y is negative 4. We can add our equations together. This will give us 15x, the 6y, and the negative 6y. Oops, I made an error there. Let's go back for a second. 2 times 2 is not 6. 2 times 2 is 4. So this should be 13. Negative 6y and 6y will give you 0. 30 minus 4 will give us 26. If we divide both sides by 13, that will just give us that x is 2. Maybe we'll sub into the top equation. So that's 3 times 2 minus 2y equals 10. 6 minus 2y equals 10. We can subtract 6 on both sides to start to work to get the variable by itself. And then the opposite of multiplication would be doing division. So that'll give us y equals negative 2. Meaning our solution, the point where those two graphs would intersect, is 2, negative 2. Now to check, we can just sub those both in and make sure they work. So in the top equation, 2 times 3 is 6. Negative 2 times negative 2 is 4. And does that equal 10? Yes, 6 plus 4 is 10. In the bottom one, 2 times 2 is 4. 3 times negative 2 is negative 6. And does that equal negative 2? Yes, 4 times negative 6 is negative 2. Okay, it's not a bad idea to take a second to check it. If you're going to check it, actually think through it and make sure it checks out. I see sometimes people will sub in the numbers to do a check and then just put the check mark next to it. And it really didn't work out. They never actually thought through it. So if you're going to do the check, which is a good idea, take the time to actually make sure it's correct. All right, this is the bottom of page 4 now. So these ones, there's already a variable by itself actually in both equations. So this might be quickest to just do substitution. Let's sub the x minus 4 in place of y. We can subtract the x over. That'll leave us with negative 4 equals 2x now, plus 2. We can subtract the 2 from both sides because the opposite operation of addition is subtraction. And to finish off the x, we'll do the inverse operation of multiplication, which is division. So we get x is negative 3. And we can sub back into either one. That top one looks pretty easy. We'll have negative 3 minus 4. So that will give us negative 7. So our answer would be negative 3, negative 7. And we could sub in and check if we wanted. 3 times negative 3 is negative 9, plus 2 is negative 7. And then the negative 3 minus 4 also gives us negative 7. So we're going to finish the video with two more, but they're a little bit messier. And really, they're only messier because of the original equation that they're given. We could either do this by getting a variable by itself, or we could do it by substitute, or we could do it by elimination. So it might be quickest to just get this x by itself here. So let's add the 3y over. So that'll give us x equals 20 plus 3y. Or you could do 3y plus 20, that's the same also. So now everywhere there's an x in the other equation, we're going to fill in 20 plus 3y. So we'll have 9 times 20 plus 3y plus 12y equals 32 minus 3y plus 2 times the 20 plus 3y. So we will distribute now. We'll have 180 plus 27y plus the 12y that was already there. And distributing the 2 will give us 40 plus 6y. We can combine our like terms over here. We can combine the y's here to give us 3y, and we can combine the constants to give us 72. Maybe we'll subtract the 3y over. That'll be 180 plus 36y equals 72. We want to get the y alone, so we'll get rid of the constant over on the left. 72 minus 180 will give us negative 108. Now, you will be able to use your calculator on our test in this unit. So try in low-risk settings, like on homework, classwork, things like that, try and do things without a calculator. because eventually down the road, like say on the SAT, there's sections where you can't use your calculator. So things where you're not being graded on correctness, like classwork, homework, try doing it as much as you can without the calculator. Say on a test or a quiz, if you're unsure, yeah, punch it in the calculator, make sure you're gonna get it correct. So we'll divide by 36, and that'll just tell us that y is -3. So probably the easier one to sub into was the x equals 20 plus 3y. So we'll sub the -3 in there. And we get x equals 11. So we would have 11, -3 as our solution. So we'll do one more together. So in this one, notice in the second equation, say if we tried to divide everything by 7, we're going to get some fractions there. So it might not be best to do substitution. Maybe we should try elimination here. So that means we got to get the variables on the left in the first equation and the constants on the right. So I'm going to start out by subtracting 10. So that'll give us 5x minus 4y equals 7 plus 3x minus 5y. Maybe I'll add the 5y over next. So that'll give us 5x plus y equals 7 plus 3x. Subtract the 3x from both sides, and you get 2x plus y is equal to 7. Well, in the other equation, all we need to do is subtract the 3y over. So that would give us 7x minus 3y equals -8. So now in this one, there's probably a clear variable that's easier to match up, and it's probably the y. Anytime you have a 1 as the coefficient of one, that's probably going to be easier, because we can just multiply the top by +3. If hypothetically you wanted to get the x's to match up, you would maybe multiply the top by 7 and the bottom by -2. You'd need one positive, one negative, so to make sure they end up as opposite signs. But it'll be easier to just multiply this one by 3. We'll get 6x plus 3y equals 21. We'll rewrite the other one. This will give us, when we add the equations, 13x is equal to 13. And when we divide the 13 over, you get x equals 1. So I'm going to take the 2x plus y equals 7 to sub back in. And you get y equals 5. So our solution, the point where those two lines would cross, is 1, 5. So there's some other examples, and I'm just going to give you the answers to them in case you wanted to practice more of them. You don't have to, because you're going to get some practice on your homework, but if you did want extra examples, you could. So that next one is 11, -3. The one after that is 1, 5. This is just so you can check your answers. You could always cover that up as you're solving it. And then the one after that is 1, -2. Now the final thing I wanted to talk about in this video is how do you go about doing homework? So when you sit down to do your homework tonight, notice your homework in your packet is the pages right after the notes, and I do that purposely so it's easy for you to flip back and review the notes for the day. So it'll probably have been a couple hours when you decide to do it, or maybe you're just going to do it right after you watch this. You could do that too today. But look over the notes just to refresh your memory, and then try the problems. If you have things that you are having trouble with, flip back those notes. See if you can um, do it on your own first. Okay, that's what number 4 is saying. And then if you get stuck, flip back. Don't just automatically look back at the notes. See if you can do it without it, and then if you're stuck, flip back. Um, if you're stuck, try and find an example that looks most closely like the one you're stuck on, and that can help you figure it out. If you are still struggling, you should at least have some work, probably. Give it your best shot, and then you can ask questions about it when we're going over the homework the following day in class. So remember, make sure to take pictures of your homework pages, upload them to Schoology. If you have any questions on anything, you could also post in the content discussion board. If you see someone posts and you know how to answer their question, feel free to go ahead and answer it. Or when I check it out at various times, I'll answer as well. But be empowered and feel free to help out your classmates if you see that you can.